Now let's move on to the other electrical quantity, which is the voltage or potential difference. Okay. Now, what is this? I think again an analogy could be made with gravitational field. Okay. You know that if you have gravitational field, this is the earth. I am showing only a small area, so I am showing it as flat, and you know that there is gravitational field in this direction. Okay. Now, if I place a mass m in a gravitational field, what will it do? Obviously, it will fall in some way towards the earth. Okay. In fact, the gravitational field could be due to any body, and it will always fall from a higher gravitational potential to a lower gravitational potential. And let's say this was at a height h2 above earth and the other one was at a height h1 above earth. When it falls from h1 to h2, it gains a potential energy which is mg times h1 minus h2. Okay. So it falls from a higher potential to a lower potential, and while doing so it gains potential energy. Okay. Now similarly, if you have an electric field, which is usually denoted by that, and then you place a charge q, it will, this is of course a positive charge q, it will fall. I mean, here I use the word fall not in the gravitational field but in the electrical field. Okay. So it will go from there to there. Okay, it will tend to go. And if it does that, it will also gain a potential energy which is q times, let's say the potential, this electric potential is denoted by V, and if this is V1, V2, it will be V1 minus V2. Okay. You see that the gravitational potential energy that is gained is proportional to the mass. Okay. And the electrical potential energy that is gained will be proportional to the charge. So we leave out this charge and mass are property of the body that is falling, and the rest of it is a property of the field. Okay, and that is the potential difference. Okay, so the amount of energy gained is equal to the amount of charge times the potential difference between here and there, and that is V1 minus V2. Okay. Similarly, here in the gravitational case, the amount of potential energy gained is the mass of the body that is falling times the potential here minus the potential there, which is g times h1 minus h2. So what I want to emphasize here is that potential makes sense only when measured as a difference of values between 2 points. Okay, it's V1 minus V2. If you just say potential at this point is something, that is not a very significant thing. Okay, so you always have to measure this voltage or potential difference between 2 points, and this is true of circuits as well. Okay. Now, as usual, we are not looking at arbitrary fields that are distributed in space and charges falling in this. We are only looking at electrons moving in wires or charges moving in wires, and the fields will be inside the wires. Okay. So the potential difference, the electrical potential difference, is very much like the gravitational potential difference. The gravitational potential difference acts on the mass, and a mass that falls in a gravitational field will gain some potential energy. Similarly, an electric charge that falls in an electric field will gain some potential energy. Okay. So when we are talking about circuits, we will not worry about potential energy or electric field. We will talk only about the potential difference. Okay. Okay, it looks like the connection has been broken for some people or the quality has been questionable. So what I'll do is I'll just pause the camera to conserve the bandwidth and hopefully things will be better. You can give me feedback on whether it is indeed better. Okay. What I was saying here is that I was trying to make an analogy between voltages or potential differences. Oh, yeah.
Video is off.
No, that's what I mean. People said
Okay.
that. Okay. So the video is off now, by the way. What I was saying here was that I was trying to make an analogy between electrical potentials and gravitational potentials that you are familiar with. Here on the left side, I have shown the Earth and the gravitational field pointing downwards. And if you place a mass m somewhere, it will fall down in the direction of the gravitational field and it will gain potential energy. It will always fall from a region of high potential to a region of low potential. Let's say it falls from a height h1 to a height h2. It gains a potential energy which is m times g gravitational acceleration times h1 minus h2. Analogously, in an electric field, here I have shown on the right side, electric field pointing downwards. If you place a charge q somewhere, it will fall. That is, it will move in the direction of the electric field. And let's say it falls from one point where I have marked a potential of V1 to another point where I have marked a potential of V2. It gains a potential energy which is q times V1 minus V2. Okay. So the amount of potential energy gained is proportional to the charge and it is charge times the potential difference. Just like the amount of gravitational potential energy gained is mass times some difference. And it's the difference between some quantity at the initial point and some quantity at the final point. So what I want to emphasize here is that the voltage or potential difference makes sense only when measured as difference between values at two different points. Okay. There is not much significance to saying that the potential at particular point is 1 volt without saying with respect to what that potential is. Okay. Or in other words, you have to say that the potential difference between point A and point B is something. This is something you have to do in circuits as well. The voltage is always measured between 2 points. Okay. So in fact, while you are discussing it among yourselves or you are thinking about it, you should always think of 2 points between which the voltage is measured. A lot of confusion about voltage comes about because you forget that it is measured between 2 points. Okay. So any questions about voltage? Any questions about voltage? Okay, there are a number of questions. One was related to electromotive force and voltage. Okay, these are basically different terms for the same thing. Electromotive force is a somewhat old term, and we use the term voltage now. And somebody asked what happens if the field is in the opposite direction or if the charge is negative. Now, if the field is in the opposite direction, it will cause a potential in some different way. Okay. Now, as I said earlier, we will not worry about fields. We will only work with potentials. And if the charge is negative, whatever happens to the positive charge, exactly the opposite will happen to the negative charge. A positive charge falls from higher to lower potential, and a negative charge falls from lower to higher potential. Okay. Now, one of the other questions is, I said that the potential energy gained is Q times V1 minus V2. So, how do we know V1? Okay. Now, when you talk about potentials in a field, you will measure V1 with respect to infinity, but it doesn't matter what it's measured with respect to. Okay. So, if V1 and V2 change by the same amount, it doesn't matter to anything. Okay. So, it's only with the value of V1 minus V2 that matters. Now, this will become more clear when we go on to discuss particular elements, because we'll only be discussing voltage differences across the elements. Okay.